How's everyone doing? Um, Maybe you can drop in the chat where you guys are joining us from. While brief introduction to today's session with Adam Holm from mapping to meaning, exploring complex systems with the Qualitative Systems Exploration Model. Thank you, Adam, for joining us today and in contributing to the seminar series. We are hosting our next conference, the International System Dynamics Conference in the Netherlands next year. We're meeting this summer from July 20 to 24, 2026. And the team is navigating uncertainty and instability, crafting future together. And you can already start preparing your work to be submitted to the conference. Submissions open very soon in January. And also, if you're not a member of the System Dynamics Society yet, here are some benefits of being a member. You get access to the journal, the System Dynamics Review, also appeal to the mentorships and discount to our annual conference. And today we'll be collecting questions through Poll Everywhere. Adam will be presenting, start his presentation very soon. And you can submit your questions through a link that I'll put here in the chat so you can easy access, but you can also scan this QR code and ask your questions throughout his presentation. And today's agenda is a 45 minutes presentation with Adam. This part is a more technical theoretical presentation, and we move to a 15 minutes Q&A about that presentation. Can focus on questions related to that, and then Adam will guide us through the software in about 20 minutes, and we'll have a Q&A also to ask questions about the software itself. And I'm happy to introduce to Adam Palm. He is the founder of the System Science Lab, where he supports organizations by consulting, building tools, and training teams in systems thinking and systems modeling. He is also a researcher at the University of Queensland in Australia, applying systems and complexity science to real-world challenges, particularly in rural and remote health. Adam focuses on ensuring that models and methods are reliable, valid, and usable for practical decision-making. And he has an extensive publication record and is recognized amongst Australia's leading researchers in systems analysis. So thank you so much, Adam, for being here today, for agreeing to contribute to the session. I've seen here in the chat that people are joining from a lot of places in the world. I see in the US, the UK, India, from Germany, Peru, Canada, Switzerland, Netherlands. So you see, there's quite a diverse crowd today. Thank you so much. That's all from my side. You can go ahead and share your screen and start your presentation.
Thank you, Fernando. Yeah, I'm having a look now at the chat thinking that is incredible. An amazing turnout from various parts of the world. All right. Hello, everyone. I'm going to share my screen and kick things off here. Any issues at all, please do yell out because I'd like it to be as smooth as possible. So what I'm going to do is go here and application window. There we go. So are we in business?
Yeah, we can see your screen.
Fantastic. Okay. Well, to kick things off, I just want to say, first of all, thank you everybody for giving up a perfectly serviceable whatever day of the week it is there for you. It's currently 2 a.m. here in Brisbane, well, Sunshine Coast, just north of Brisbane. So I'm raring and ready to go. I'm looking forward to it. And I'm going to be talking about QSEM today. There seems to be a bit of a buzz around QSEM and an appetite for this in system dynamics. And so let's kick things off with a bit of a technical overview of QSEM, the journey that it's gone on and traveled on. And then from there, as Fernando has outlined, we'll sort of dip into the software, have a look. And there's been a lot of requests recently around the actual software itself, how to use it. So I'll go through a bit of a brief introduction to how you can actually use this experimental version of the software, because of course it's always in development. Okay, so to kick things off, let's go to my current work and activities, just for that contextual background there for you all. So Yep, founder of System Science Lab, and QSEM is associated with that. And in my other life, I'm really enjoying my current fellowship in SD modeling, which is actually looking at qualitative and quantitative approaches in system dynamics to model one of the biggest crises we have in healthcare over here, which is the rural healthcare workforce shortage. And when you think about climate impacts and extreme weather events on top of that, we need some really sophisticated modeling approaches to sort of address that problem. And a recent trip to Norway to visit colleagues was standout. It was fantastic to look at soft systems modeling, fuzzy variables and intangibles, and how to incorporate those into formal modeling platforms. And the reason I'm outlining that is because I have a very strong interest now in simulation modeling, but I've recognized there's also a lot to be gained from the space that QSEM is based within. And so bridging those two worlds is really important. Now, of course, I'm an academic at heart, so I have to have the mandatory definition of term slide. So first, participatory SD and qualitative SD. In terms of participatory SD, most of you, if not all of you, will be aware that there's three traditions in participatory SD: GMB, participatory SD modeling, and community-based system dynamics. All of which, they all overlap in many ways, but they do differ depending on the participants involved, the model type, and the purpose of the model you're building, level of involvement. You could say the positionality of the researcher and so forth. But I'll try not to slip up, but for moving forwards, I'll use group model building, GMB, as that general term for participatory system dynamics. And when I refer to qualitative system dynamics, I refer specifically to non-simulated applications. But that doesn't mean, as I think we'll cover this as well, this special issue in System Dynamics Review, it was fantastic in 2024, that qualitative aspects of system dynamics, which can be very detailed and meticulous in their application, are critical for that broader structure behavior modeling process, that formal aspect of modeling. But for this purpose, non-simulated. Okay, what is QSEM? The reason we're all here. So QSEM supports researchers and teams and participants in those group model building settings, or indeed, you can use existing data and information, but it explores and allows teams to explore system structures. So when you're developing causal loop diagrams and qualitative models in participatory SD, there's a need at the moment to be able to offer process traceability, justification, prioritization of why particular factors, why particular feedback loops, what are the significance and importance around those particular elements in relation to a problem. And QSEM uses impact, control, and time delay scores, these metrics, to effectively allow users to hone in on particular elements and provide a reason for why they're highlighting, for example, reinforcing loop number 3 with 8 variables, or balancing loop number 11 there with 2 factors. Like, what is the importance of those structures in relation to all of the others in the model? Now, as these causal loop diagrams and non-simulated applications appear to be growing in popularity at the moment, models can get complex and interconnected very quickly. And QSEM really allows us to cut through that complexity and allow with that sense, or afford that sense-making process. And it integrates into GMB processes, and we'll go into this in more detail. And the need itself, so my sort of journey so far to this point has been undulating and fluctuating, and it's gone round and round in circles in a way, but it's always come back to how do we make our methods usable? How do we understand complex systems when working with them? But also, how do we ensure that our methods and models are robust and rigorous in their application? And so going back a fair while now, several years, I undertook a lot of reliability and validity testing of systems methods in the socio-technical systems domain, looking at large-scale loss events and incidents. and adverse events. And I wanted to make sure that our methods were replicable, transparent, and repeatable and accurate, especially when two different people would use a method to understand why an incident occurred, a big loss event, think Deepwater Horizon, for example, and the outputs would have to be similar, and they'd have to build an accurate representation of the system in order to then devise appropriate safety measures and interventions. And so I've done a lot of reliability and validity testing in that space, and I sort of carried that forward with me when I've applied it to SD and in this case QSEM. So QSEM effectively emerged from that sort of that interest in reliability and validity, but also needing more from our models in a particular space. And I know we need leverage, we need policy interventions we need confidence in policy interventions, but oftentimes we don't always have the time and the resources and means to go down that formal modeling process with, fully fledged quantitative stock and flow modeling. So trying, along with many others, of course, to bridge that gap, that divide. Bit of a busy slide. There's a lot of text, but here, this is a sort of a methods landscape, a continuum, if you will, of where does QSEM sit positionally in that landscape. So on the left of your screen there, you've got non-simulated applications, and on the far right, full sim. So full sim, of course, SD simulation models, think classic Forrester and Sturman. And on the far left, you've got QSEM along with causal loop diagrams, the cross-impact matrix technique, which we'll talk about, participatory systems mapping. In the middle, you've probably heard of, I've just highlighted it there, but fuzzy cognitive mapping seems to be quite popular at the moment. That would be a quasi simulation ready approach. So QSEM is further towards the left in that participatory SD space. However, it doesn't mean that these approaches on the far left are non-numerical either. They can be quantified and use elements of quantification and analyses within them. So hopefully that helps just position where QSEM is. And I thought this was important to flag early on. I know we've got a 45-minute presentation here, plenty of time, but I've really, I wanted to make sure that this was in there. And this is around the fact that early on, going back, 40, 50, 60 years, causal loop diagrams were used as a way to formulate a dynamic hypothesis pre-simulation, or indeed they were used in an expositional or communication sense when you developed a simulation and to communicate that architecture to stakeholders. Still used in this way and should be used in this way, but we're seeing now CLDs being used as these standalone mapping tools more and more. That was never initially their intended purpose, but clearly there's a lot of value and utility in developing causal loop diagrams of systems and allowing the discussion to be had around that. And so QSEM sits in that space, of course, but I wanted to recognize the strengths of full simulation in system dynamics and how important it is if you want robust leverage point identification and those policy levers over time, over an extended time horizon, and to have confidence that you can understand why the model is producing a particular behavior. It is essential to use simulation modeling. But the strength of qualitative SD cannot be understated either. For early stage conceptualization, it's very accessible for stakeholders. It can be done in a relatively speaking, short amount of time. But there's still a lot of work involved, of course, as you all know. And it's an important step. So just flagging the strengths of qualitative SD there. All right. Moving on to, looks like we're on to reinforcing loop one here. Automation transition. The remainder of the webinar today, the evening, the morning, wherever you are in the world, will be on spreadsheet origins, where QSEM began, and that will just help to clarify the journey it's been on and how it functions as well. So when you use the software, you're like, okay, that makes a bit more sense now. I understand where that's being calculated from, that particular aspect. Then the midway on automation and the full stack development, where we are today. So we'll cover the background and technical processes, a lot of spreadsheets and things like that will be shown. The first two phases of QSEM, the automated phases. Phase 3 is an archetype identification phase, which is on its way. Now, good news as well. I've just found out 2 hours before this webinar, can you believe that the the paper, if I refer to the paper, that's the QSEM paper, has just been accepted. So I'm really looking forward to sharing that with you all. And it comes with a technical guide. And then we'll go through the software as well and do a basic demo. So the QSEM methods trek, where did it sort of the origins to where we are now at the Snowy Peak, and hopefully there's still a lot more climbing to be done. Started in the Welsh Government context, a piece of commissioned work in late 2022. That led to a series of causal loop diagrams. I think there was 11 subsystem CLDs. And QSEM sort of was born out and emerged from many of those subsystem CLDs. And really in response to this need for more from the system maps that we generated there under those real world project constraints. And that was 2023, 24. And then more recently there, number 4 and 5, as we climb higher and higher. Look, at the moment, we're at further development and refinement of the framework. And really to progress this experimental version of QSEM. It is just in beta phase at the moment. So we're receiving a lot of really good feedback from the system dynamics and systems thinking community at the moment to really start to refine it and improve it and enhance the software. So what you'll see later and what you've probably jumped in and had to play around with already is always development. It's an evolving piece of work. And the one thing I wanted with QSEM is to listen very closely to what people want all the time to improve it continuously. It's like a growth mindset there. And in terms of that backstory and origin, with James and Duncan, we really wanted to identify factors with the Welsh Government that influenced dietary choices of Welsh households, and to begin to reason about where can we intervene within these food systems to be able to shift the population toward a healthier and more sustainable diet. And so we only had sort of around, as you do, 12 months to deliver a sizable body of work, but it was fantastic, great experience, love working with these two and the Welsh Government. So this is the QSEM process. So it's probably quite small for you there if you've got a smaller screen. It might be a tad hard to read. Just note, though, however, we have the orange box there, model development, the blue box, which is system factor classification, the green box, loops of interest, and the red at the bottom, archetype identification. Think of it as a systematic process that you'll go on when you apply QSEM. You start with a model. Now you can develop a model in existing software and then rebuild in QSEM, or you can just build in QSEM straight off the bat. And to do that, you can use established approaches. You've got your pre-model scripts, your group model building scripts. So you've got hopes and fears, your concept model, causal mapping with seed structure, and so forth. And then you've got various other sources. So of course, your scientific literature, existing data and information. And we're seeing more and more people use, interviews and focus groups to build causal models at the moment. So you have a model, and then think of it that QSEM is now applied once you have your model. So it's late stage system conceptualization, participant approved or researcher finalized, even though, model development and it is very iterative. We're always improving our models. QSEM allows for that. So you've got your model. System factor classification involves things like a direct dependency matrix, which we'll talk about, and then the actual system factor classification spreadsheet to inform a system grid. Now, this is, of course, how it all began. This was the manual process. This is what I had to go through to get to the software. And for those of you that are more technically minded, this might be enjoyable to go through the bases and theoretical foundation of QSEM. Then we also have, as part of phase 1, the system grid, where factors within your CLD will move around depending on your impact or control coefficients. So you can start to ask yourself, oh, that might be an important factor for these reasons. Let's explore that further. This may be a driving force within the model. Perhaps that could change when you change impact to control. And perhaps participants, when they see this, just like the Welsh Government did, can understand a lot faster the roles of each factor within the system. And then you'll code the model based on your system grid. In terms of loops of interest, this is when we move from factors in your causal loop diagram to actually start to explore feedback loops. You'll actually have something called a dynamic loop register. And the dynamic loop register will auto sort depending on the weightings that you give to impact and control. And then we have various other metrics I'll talk to you about: composite strength, the number of steering factors that lie along a particular feedback loop, which may be like sort of cities that sit within major highways, and then independence, which tells the user what are the sort of feedback loops that share minimal overlap with other loops that may, trespass into various other subsystems within your model and cut through the model more broadly, and that are relatively unique. And so you can play around. The idea is to play around with your dynamic loop register so you can really start to explore and understand that system. And I'll talk to you how we get to that point as well. So when you go back to your CLD and highlight your feedback loops, you've now got more reason as to why you've actually highlighted those structures in your model, those factors and feedback loops. You can provide reasoning for that. Okay, back to our macro level view here, our causal loop. GMB scripts are really important. I really like them. They add a lot of rigor to the group model building process. Peter Hoffman's book, Community-Based System Dynamics, is a fantastic resource in this regard. And I've got an example here on the left of a few scripts, and then on the right, how QSEM can integrate with those scripts. So effectively, you've got, for example, here, places to intervene. So you've got your model, and that's a post-model script. And that's where you can start to use the script, that protocol, to identify places to intervene within that system, and the potential for those places, those actionable insights to actually translate into desirable practical outcomes. In QSEM, you've got the dynamic loop register. And what you might do is look through the dynamic loop register and consider factors and loops, feedback loops, that are important in an impact, control, strength, and independent sense, for example, and relate that back to the protocol, places to intervene. So they talk to one another and they can enhance one another in this regard. And so you're using the outputs of QSEM to support your group model building script process. And there's some examples there, and you can obviously go back to this in the recording and look at the examples there. And there's plenty in the paper as well, how that could look and how that works. A little on contribution here in terms of knowledge and practice. Now, this is probably the single most important reason as to why I sat down one evening and said, we need more from this huge interest and growing popularity in the use of standalone causal loop diagrams, qualitative system dynamics applications, particularly in, like the areas I come from, public health, healthcare, medicine, and implementation science. And so I wanted to add that rigor to all of these standalone causal loop diagrams when we talk about, I'm sort of careful when I use the word leverage or even potential leverage and leverage points. When I talk about qualitative SD, I prefer to save the word leverage for simulation modeling. However, it's still important that we add rigor to this standalone paradigm that's emerging and continues to emerge. And that's where QSEM was born. And really, in a practical sense, it does support decision makers translate CLDs into potential actionable insights that can then either be explored in formal modeling or perhaps tested, depending on the level of confidence in the real world, to those systems. But also it's a learning tool. It's to provide that education to participants and indeed researchers around, in that boardroom setting, in situ, in a dynamic environment, what it all means when we look at these complex models. And on the right there, you can see it's a really well-presented model, and it's a great paper, this one, The Converging Perspectives on Adolescent Obesity. And you can see there's 207 loops in that model. 207, that's a significantly high number of feedback structures. But out of that 207, do we ask, which should we be prioritizing in terms of our problem space? Which loops are impactful? Which are rare? Which do we have potential governance control over or potential over? QSEM will allow you to answer these sorts of questions, which factors are important. And so it's applied to models like this. Models like this are a perfect case study for QSEM. And I've done a quick search recently of the number of academic articles that reference causal loop diagrams in just the title and abstract alone. And you can see this is just in the health literature. I think it's actually rocketed from 99 in 2020 to 177 in 2024. That's Web of Science more broadly. In health, it's 24 to 57 in that same time frame. So we're seeing a tremendous growth. And here are some examples from this year. I mean, there were many more, of course, but here are some examples of causal loop diagrams. And out of that, the third one along would probably be the one with lots of color there and a tremendous number of interrelationships. QSEM would be applied on a model like that to make sense of it. That would be a really good example of how QSEM could be applied. It could be applied to the others as well, but it would make a lot of sense to apply it to that model there. I can't proceed without mentioning a fantastic special issue in the System Dynamics Review in, I think it was late 2024, on qualitative aspects of system dynamics modeling. If you haven't checked it out yet, I strongly encourage you to. There are a number of articles in there that really inspired QSEM. I took some of the best ideas and approaches from these papers and put them under one roof, if you will. I'm not saying fully in the extensiveness that each individual contribution here with its particular approach made, but I tried my best to synthesize and put it into QSEM, these lessons learned, these approaches. Really good. Check it out. The special issue was quite instrumental in all of this. Now, application considerations for QSEM. So there's plenty outlined in the paper, and like I say, it comes with that technical guide. So I'll cover here briefly the intended audience, if that's not clear yet, workflow options available, and the software use. And there is a lot to this, so I'm going to focus first on the audience. And really, QSEM is designed for researchers and modeling practitioners in systems thinking and system dynamics who work with participant teams to solve real-world complex problems, okay, across various domains and systems. The technical guide I'm going to be able to share with you now the paper's been accepted. It's about 30 pages. And the technical guide will outline a lot of what we'll go through today, but it will be a useful reference point for you moving forward. And the electronic spreadsheets will all be available as well as the software. And in terms of workflows, you'll note that you can apply the full approach. The full QSEM approach is 3 systemic learning labs, a lot of group model building scripts to make sense of models. And really, you can tailor the in-person or online workshops in terms of the length of them, depending on how the project needs call for. But ultimately, the full approach is quite comprehensive. And partial is you'll have shorter check-ins after each phase with participants, and light is you'll just go through the whole thing in one go and then have a check-in basically with your participant teams and groups and end users. The software use originally, Stellar was absolutely critical for this. And now I love geeking out on Stellar and talking about how this all came to be at the back end. So I'll cover that a little bit and go into some details around how we extracted loops from the documentation viewer and so forth. That may be of interest. And it's important to flag after the use of QSEM, there are still other approaches you can go away and use. Like there's an example there of a paper that uses this really interesting sort of leverage point clock dial where you can sort of look at how you can have more confidence using the scales of leverage within complex systems models to enact change within systems. All right, QSEM phase 1, system factor classification. Let's jump in. We're here for context. If you recall, the QSEM flow, the process, we're at that direct dependency matrix stage and systemic learning lab 1. Now, phase 1 of QSEM draws on a lot of existing ideas, and I went down a rabbit hole when doing this around the futures research, scenario planning and management, and realized, when you sort of go back through the literature and research and realize there were some really significant lessons to be learned from times gone past, sort of, as long as in some cases multiple decades ago, and fantastic contributions here. And really, QSEM phase one classifies factor types within a CLD based on their local impact and control potential. Now, impact and fuzzy weights assigned to connections is something that's been around for a while, but control is new in QSEM. Control was added because we wanted to be able to not understand what's important in a model, but can you do anything about it? That was the key thing there. And so it translates these qualitative group level inputs into a consensus set of quantitatively summarized insights. So, that's an important part of what QSEM does. It's a vehicle for allowing the group to express what they feel is important and turn that into quantitative results and provide that light analyses to a CLD. And it draws on those various methodologies there on the screen. And so let's say you have your causal loop diagram. You've developed it via an established means or process, group model building scripts. Perhaps you've used existing data and information alongside a participant group. Let's take a pragmatic approach. You have a CLD you're happy with. What you'll do is you'll assign scores to each relationship, impact and control. Now that's derived from the literature, fuzzy modeling, and impact is on a scale of 1 to 3, control on a scale of 0 to 3. Now, of course, QSEM allows you to do all this, but this is how it began. And you can see an output there from Stellar Architect. Now, in terms of definitions, impact is defined as, or you can ask your participant teams this, should I say, is, what is the extent of the impact of the driving factor on the receiving factor, small, medium, or large, fuzzy determinations. And that's around measuring how strongly the driving factor will influence the receiving factor. Control is slightly different. That's to what extent is it possible to influence the receiving factor by intervening on the driving factor or its effect. So then you can assign no control, minimal, moderate control, or high control. And the important thing there is control starts at 0, because if you have a relationship and a set of factors in your CLD already, then you've already automatically decided that there has to be a level of impact. That's why impact starts at 1. Control doesn't mean you have governance over that relationship, though. So that's why it starts at 0. And just to throw a little bit of confusion in there, yes, subsequently, since we developed the original framework and went through this manual process and all of this just went through this journey, we've added time delay as well. And I'll discuss this conditional delay value later. But effectively, what you can also do when you look at two factors in your model and the relationship between them, you can start to also add a fuzzy weight around the delay time. So 0 is no delay, instant effect between two elements. 3 is long. Perhaps that's multiple years to decades. But you can define that if you wish. And you'll ask, how long does it typically take for the impact of the driving factor to show up in the receiving factor? So what I did initially, so I'd assigned with the participant group, in this case, the Welsh Government, we'd gone through and we'd assigned impact and control to every connection in the CLD. It sounds like it would take a long time, but actually it's a really valuable process to assign impact and control to connections in the CLD. The discussions that come from that are very interesting. It can be fruitful. It can be challenging, but it forces people to think deeply about what does it mean when we say impact? What does it mean when we say I have control over this relationship? Is it perceived control? Is it actual control? It's a great part of the process. And as we know, systems modeling and analyses, the journey is often more important than the destination. The insights that we gain during that process are critical, and documenting them during QSEM process, and you can annotate models, is really useful to the end goal. So you turn that model, including the impact and control scores, into a direct dependency matrix. This is all done for you now. Now you'll understand in the software why we have the DDM tab. So when we go through that later, you'll be like, okay, yeah, that makes a lot more sense now. But in the early days, I had to turn that CLD into a DDM itself and transfer all of those scores over. So you can see there in your columns, you've got values in the green shades. That's your impact and control. And that allowed me to compute an active impact value, an active control value, okay, in terms of the rows. And then in terms of the columns, I had passive impact value and passive control values as well. And then I basically carried those scores over. You can see there in the first 4 columns, AIV, PIVs, ACV, and PCV, and carried them forward. I would basically weight them according to impact and control, and then I would normalize them so I could plot a system grid. And that way I could start to look at what are the potential steering factors in this model? Factors whereby there's a lot of outgoing impact and or control, depending on the weights that you assign, but not a lot coming in. There's not a lot of receiving forces for this particular factor. Could this be something of interest to the participant group? What about those measuring factors, those points of observation within the model where there's a lot of passive force. There's a lot coming in and being received, but there's not a lot going out. Could that be of interest to the participants? Doesn't mean it's necessarily a point of leverage. Certainly not. It just means the structural footprint of the model and how you've built the causal loop diagram has led to this point based on the impact and control scores, meaning that let's discuss this now using a group model building script. Let's explore it more. And the amazing thing is, participants and stakeholders, despite only sometimes having very limited touch points, really understand this. They really do get it, and they enjoy the process of going through it. That's effectively just how I calculated the system grid there by just computing the AIV and ACV, combining them with the chosen weight. In this case, just in this example here, I'm going to put 40% to impact, which by definition leaves 60% to control. And by doing that, by changing that coefficient, you'll actually see the factors on that system grid move around in their positional space. So stakeholders, they could, get the Excel spreadsheet. They could say, oh, I'm actually interested in control-based factors. So they might put impact to 0. And that way, the factors would move around, and then they would have a discussion around that and would plot it. Of course, it's great to be able to not have this done manually anymore, go through that manual process, and to have the software do all of this. So hopefully it's helping to just take you through that journey of how we've got to this point. Here are the definitions of steering, measuring, ambivalent, and autonomous. Steering have high weighted active values and low weighted passive values. And on the flip side, probably the complement of that would be measuring, would be low weighted active values and high weighted passive values. And steering factors exert relatively strong, and the key word here is local influence and control. So think of it in relation to their nearest neighbors. So the factors that affect a factor and the factors that factor affects. It doesn't look at whether something is steering necessarily in relation to the propagation of influence through a network, because it's a direct dependency matrix. But as soon as we started to multiply the matrix over and over and do some more sophisticated things, we lost the stakeholder group. Like, it's very easy for people to then say, okay, it becomes a black box, basically. And I wanted QSEM to be very transparent across the whole process. But that still doesn't mean it's not a steering factor in relation to all other factors, because it's a relative measure. So it's a relative score. So it still looks at the entire causal loop diagram and says, this is a steering factor in relation to all of the factors, for example. Same with measuring, ambivalent, and autonomous. And you can see the definitions there as well. So we've gone through this, but a 40% impact score reflects how the chosen weighting incorporates greater control. So a factor might be influential, but not very controllable, or controllable, but not very impactful. So balancing this and continuously, changing it and playing around with your slider is really useful. It's good to explore the roles of various different factor types. And this is an output from a particular project there. You can see top right, there's a very small CLD schematic. That was in the early days when this was indeed manual. I had to go back and sort of assign the new colors to every factor within the CLD and update the CLD manually. And I was like, we need a better approach to do this. This has to be smoother. This has to be much easier. So when I developed QSEM, the coding and the colors applied to all the factors are applied instantly. So you can just adjust your slider, refresh your phase 1 button in the toolbar, and you'll just instantly see the updated results. Well, that's phase 1 down. I think we're going all right for time. We're on to phase 2. The archetype identification phase 3. I'm really looking forward to being able to share that with you down the line. And there's some really exciting things with that. But phase 2 starts to dig into loops of interest. So we start to actually move from factors to feedback. And feedback is the name of the game. feedback gives rise to behavior, or the system structure gives rise to behavior. And so loops of interest has to come before archetypes, because archetypes are predicated on feedback and interlocking feedback and so forth. So in terms of phase 2 framework context, where are we now on our process? We're in that green area there, phase loops of interest and systemic learning lab 2. So I've suggested some post-model scripts there. Whereas in phase 1, the scripts were dots, nominal group technique, and reflective feedback. They seem to be really good GMB scripts. Phase 2 uses model review and places to intervene as the scripts. And we use the outputs of QSEM and integrate them with those scripts instead. So what is loops of interest? So it draws on the same direct dependency matrix from phase 1 to now analyze the composite or the multiplicative impact and control strength of each feedback loop within your model. Now, once you've done that, you can further prioritize your loops based on whether or not they go through steering factors or other factor types and their degree of overlap with other loops using a flexible approach. Now, I will say for transparency here, I think in the software at the moment, I use the conditional delay values. So I can actually prioritize loops that are relatively fast in effect or slow in effect. Okay, so we're looking at the speed at which that feedback loop operates. I'll add back in the steering factor, loops passing through steering factors. That's a complicated process, but that will be on the way, as well as the archetypes. More importantly, though, the objective of this phase now is to explore loops within the dynamic loop register, the DLR, according to various criteria as above. And that really allows for that justification in your analyses. So these are the 3 metrics. So this is after you've prioritized your impact and control. You've got something called a normalized loop composite value. So that represents that multiplicative impact and control strength of a loop within your model to capture that compounding feedback. Now, this captures loops that have relatively strong impact and or governance potential, depending on your slider in relation to impact and control. The steering factor count reveals loops that connect those influential factors or potentially influential factors to other system structures. So they're junctures of sort of points at which other loops may emerge from. And it's useful as an exploratory first pass. The conditional independence value is a little more complicated, but there's 2 options here, a toggle function. You can highlight shorter loops that are minimally shared with other loops. Typically, shorter loops will always be the ones that have least overlap. There's less opportunity for overlap because they contain fewer factors. Whereas if you look at the normalized adjusted independent loop value, and in QSEM you'll tick, please prioritize longer loops, that will highlight longer loops within your model that are relatively distinct compared to other loops. We'll go through that as well. And this is the most recent addition. This is the delay scoring. So you can see top right there, there's a load of numbers. Now that 3, that 2, 3, 3, 2, 3, 1, etc. That's the delay value that a user has assigned to the relationship between each factor within a feedback loop. So you can see 3 is a large delay and 0 is no delay. That allows you to compute a relative loop delay value. So you sum up basically all of your delay values, then you adjust them by dividing by the number of factors within the loop, and then you can normalize and you can invert that. So you can prioritize slow loops or relatively fast loops. So that's sort of been added recently. And it's, again, really interesting to discuss this with participant teams and say, why do you think that's a relatively quick effect between factor A and B? What's the reasoning for that? And someone else in the group will say, actually, I'm not sure it's small. It's probably more like a moderate delay for these reasons. And you can have a discussion around that until you've achieved consensus. And in the early days, of course, this is how it looked. The dynamic loop register looks very different now in the QSEM software itself. But early on, there was this, and you'll have access to this, by the way, soon, hopefully when the paper's published. You can sort the loop register based on the weight assigned to impact and control, and then your composite steering and independence scores there. And that's your longest loop independence switch on the right. So if you toggle that to yes, this will auto sort this table on the left here. So at the moment, balancing loop 8 with 12 variables happens to be the top loop according to these coefficients that you can see on your screen at the moment. So those can all be adjusted at any time, and then you hit sort loop register there. So that's where that sort of came from. And to get there, I'm only sharing this part here because I thought, what a interesting way to get to the dynamic loop register in the early days by using Stellar Architect. And it involved, creating the CLD in Stellar, adding loop labels to every feedback loop, which allows the documentation viewer to be populated, and then importing those strings into a spreadsheet and then assign the loops, all of these metrics and so forth, and then go back to the DDM. And so it was quite an interesting and convoluted process. It worked really well. And this really set the scene for, we need something more powerful, specific to QSEM. Stellar is incredibly powerful and a great piece of software for simulation modeling. It really is. But for something like QSEM, which sort of sits in a strange place, a middle ground between the qualitative and the quantitative, and it uses fuzzy weights and concepts of impact and control, there wasn't really anything that existed. So I had to be very pragmatic with how I got to QSEM and the software. So you can see there the CLD that was created, and then I had to dock the loops panel and assign labels. You can see here, every feedback loop was assigned a label just so I could populate the documentation viewer to get all of the feedback loops and then, import them and do all the fancy cleaning and things like that in spreadsheets. But the beauty of it is it allowed me to get to this table where I could present the loops of interest results. So now when I was, writing up my journal articles or reports for stakeholders and so forth, what you can do is you can present your loops like this. So you can say, balancing loop B812, here's my pairwise weighting coefficient. I assigned 40 to impact, 60 to control. I wanted to give a bit more to control, a bit more emphasis on control. Can people do anything about it? And then you can see here the composite score, the steering score, and independence. And that looks different across. I've kept this the same on this example here, but you can actually change impact and control and present all of your loop metrics. This is one way of presenting it. Then when you highlight your various feedback loops in your model, you can have reasoning behind them. Of course, in QSEM now, this is how it looks. So when you see this output, I've had lots of questions around this, and that's why I'm going through this today, because a lot of people have said, how does the dynamic loop register work? What's the background to it? How are you calculating this? And so that's how we've gotten to this point here. And so you can click the highlight button here, and it will highlight the loop that you've prioritized based on your coefficients within the software. So this is the wrap up before we dive in, and I'll take people through QSEM itself, the software. Importantly, QSEM is optional and complementary. If you use it, fantastic, but you don't have to. There are many other approaches and techniques and modeling choices available. I think it's brilliant. We need that plurality of methods and approaches in the literature and in the practical toolkit. And so, but really, perhaps consider using QSEM if you're starting to build those standalone, large, feedback-rich and complex causal loop diagrams where you're struggling to make sense of it because it can be sometimes very hard to simplify and abstract and create a parsimonious model. That should be the goal, but if not, perhaps there's approaches like QSEM to help you with that. The loop strength values reflect single loop influence, not dynamic accumulation or loop gain over time. If you want to do something really powerful, use loops that matter in Stellar, for example. You'll get outcomes over time and understand how dominance between reinforcing and balancing effects can shift dynamically and lead to stable or unstable equilibrium within systems. And temporal behavior requires those sorts of packages. QSEM, again, is just one approach. It has strengths and it certainly has limitations. Okay, but the idea is to just move that needle a little bit further forward and to help people. And importantly, get people to enjoy modeling. This is such a great place to be, system dynamics. And, we want people of all walks of life to take the reins, no matter what level they're at, and actually enjoy the process and learn and have fruitful discussions and really contribute to creating change within this world that's just growing in complexity at the moment, it would seem. and to address that knowledge and practice gap. So we've gone through this. That's fine. We've understood the benefits. But what I will highlight here on this slide here is that sometimes in a group model building setting with various participants, it could be a multi-stakeholder group. You may have observed yourself that you'll have these power imbalances at times, and sometimes a lot of people have a lot of experience with the systems that they operate within, but they're not always willing to speak up in that sort of setting. With QSEM, because of its approach to assigning impact and control scores, there are many ways of doing that. The facilitator can say, independently, please note down all of the impact and control scores on this model, and we'll start to discuss that as a group. It gives people an opportunity to record them on their own or within smaller teams, and allows sort of those stronger voices that sometimes dominate occasionally to actually sit back a little bit and allow other people to have their say as well when we build models. And so really it aids with the navigation of those complex interdependencies within systems and allows the group together to collectively determine what's important. All right, so I think that's what I'll look forward to sharing with you all as well, the QSEM technical guide, and I think we'll jump in and perhaps have a look, Fernando, if there's maybe go to
We do
questions
have a
first.
few questions here.
Now,
I'll keep an eye on the watch, so we still have a demo session, a software demo session, after we answer a few questions here. I'll start with this one. That was the first one to be sent here. To what extent is QSEM sensitive to the level of detailing intermediary pathways? This is a recognized challenge in network-based analysis of causal loop diagrams where differences in granularity can meaningfully alter the result.
yeah, okay. I'm not unmuted, am I? Yeah. Intermediary pathways, level of detail. It's challenging in QSEM to look at pathways that extend beyond that local system hub of factors. So the way to think of QSEM is the relationship between a factor and its nearest neighbors. So if I'm understanding that correctly, at the moment, QSEM doesn't look at the propagation of influence throughout a network. I know network-based analyses of CLD, which colleagues like Luce has critiqued recently, has its limits. QSEM tries to separate itself from network-based analyses where it doesn't use those traditional metrics that network-based analyses use. But if I'm understanding the question correctly, the only thing I can say on that as well is that we're looking at changing the granularity of the scoring system from a scale of 0 to 3 and 1 to 3 for control and impact to look at a scale of 1 to 7 or 1 to 5, which will increase that sensitivity. But it's a good question. I'm just trying to sort of figure out what it means with the intermediary pathways there, Fernando.
Right. Is the person who asked the question want to clarify this question? Well, maybe you can type in the chat a little bit of clarity and while we answer another question here. Let's go to this one then. How is this method similar or different from using the DMATL multi-criteria decision-making tool, which is also includes a score 0 to 4 to assess the causality and allows to draw IRM, the influential relationship map that can be tested to be translated into a CLD?
Yeah, there are great question, really good question, because there are a lot of other approaches like DMATL and there's Marvel, there's diagrams to dynamics. There's fuzzy cognitive mapping, and there's a lot of approaches that use these fuzzy weights. And how I would say QSEM differs is in its focus on feedback loop identification and prioritization. QSEM has overlap in terms of the scores like 0 to 4, certainly with its fuzzy weighting. So similarity is there in terms of prioritizing elements. But where QSEM differs is its focus on normalized loop composite values, normalized steering factor counts, conditional delay values, and its focus on feedback and bringing out feedback loops. But I think that on that note, great question. And all of these approaches are fantastic. People should check them out because they really add that rigor and level of detail to CLDs and other similar systems mapping approaches so you can get more from them. So yeah, great question.
Next one here. Would you say NWAV and NWPV contracts similar to MIC and MAC on?
Yeah, spot on, spot on.
Mm.
So matrix multiplication applied to a classification or micmac is a fantastic approach when dealing with interconnected or highly interconnected networks where convergence and
Mm.
stability can be realized. So what you do in micmac is you multiply a matrix over and over by itself until convergence is achieved. By doing that, you move from a direct first order analysis to sort of a paradigm of multiplication where factors within that quadrant or the quadrants normalized weighted active value and weighted passive value, which you're correct, the questioner is correct that it is similar to MICMAC. They will continue to move around until convergence is realized. It's sometimes challenging, though, to apply a matrix multiplication approach to a CLD, even though there have been applications in the literature that are used to use MICMAC to build a CLD. And there's actually one paper, I believe, off memory, that has applied MICMAC to a CLD and achieved convergence. It's really cool stuff. But when I applied MICMAC to my CLDs in the past as a test case, I couldn't achieve that true stability, that convergence, where everything stabilizes in the framework. So I chose to use a direct dependency matrix. And on that, stakeholders understand how a direct dependency matrix works in relation to computing phase one results. But as soon as I spoke to people about MICMAC, it's fantastic, it's great, check it out. But the participant group sort of didn't quite follow along as much. But yes, is the answer. It is similar.
Thanks, Adam. So is it possible to apply the QSEM with indigenous populations from LMICs that generally have low level of literacy?
That is a fantastic question in terms of accessibility and allowing as many people as possible to engage with these concepts. Really good point, especially in community-based system dynamics with marginalized groups, vulnerable populations. We need more in that space. The answer would be yes. I mean, the concept itself of QSEM, I've tried to make them as simple as possible. But what I would be open is if the questioner reached out to me and I'm willing to learn from Indigenous populations, vernacular and terminology and cultural sensitivities there, I will work with those people to ensure that I could probably produce a guide that goes along with QSEM for various other populations to make it as easy as possible for those people to follow along. I'd be willing to do that. Please do reach out. At the moment, it can be technical, but I'd like to be able to make it as accessible and listen to the community.
We have another two questions here before we go to the next part of the presentation. And in the first steps, you could creating CLDs. I feel we need to strike a balance, taking time to understand how our problem is emergent from feedback processes, rather than infinitely connecting factors and only making sense of them afterwards through the meticulous approach you've developed.
Yeah, brilliant. Absolutely brilliant question. On that, I'll say very briefly on that question is the use of large language models and all of that. Whilst it's useful and we're seeing a rise in the use of large language models and AI and agenta AI and things, we can't lose our core practice. We can't let go of our inherent human sense making when we're dealing with these complex approaches and systems. And it relates to this. QSEM is an analytical layer that's applied to a model, but ultimately the model itself, as this questioner rightly identifies, the model itself is built based on human experience, experiential insight, group discussion, and participant sense making. So the analysis of QSEM is only ever as good as, like you said there, the striking that balance as the model itself when we co-create a CLD. So if we can go through that process and use pre-model scripts, and if we can be transparent and replicable and clear on how we've gone about creating our initial conceptualization and causal architectures, if we can make that clear, and engage a diverse audience of multiple stakeholders who all of which, have important insights to make, then QSEM may be better placed to explore that system. Otherwise, we're just taking a quantitative paradigm and applying it to rocky foundations. I think the foundations need to be strong. So I think it's a great question in that regard. And there's a rich history around group model building. And I think that the two, when married up, when done properly, can produce the results we want. So I agree. Good question.
This is the last question. I locked in the Q&A for a moment so we can still have time for the second part of the presentation, and I will reopen the Q&A soon after Adam respond to this one. So are you planning to integrate more mixed methods in the QSEM, for example, supporting SD, ABM group modeling like AnyLogic?
Oh, goodness me. I think QSEM's pushed my limits as it is. Crikey, you're a tough audience. I think that, I mean, I absolutely think that you've seen applications in the literature where SD and ABM are combined and we go to the agent level, within stocks themselves. And I think, oh, what great research that is to really triangulate data and throw multiple tools at the problem. In this particular case, I'm thinking that the archetype identification approach that will follow and will be hopefully automated will keep me busy for a number of months to come. So I can safely say I don't think so.
Thanks, Adam. You can go ahead and share your screen again. I'll reopen
Okay.
Q&A now. So Adam will give us the demo session of the software now and guide us through it. So the Q&A will be reopened, so you can submit questions related to that part now. Thanks, Adam.
Thanks, Fernando. Yeah, thank you everyone for those questions. They were brilliant. I'll just share my application window here. Okay. So what you can see here is the interface. Now I'm going to reset the canvas up here. Now, FYI, I'm going to, because of the number of questions that have come through, or what, to my email, this is to System Science Lab, around how to actually use the software. And now you know the technical background and how we've got to this stage. I thought I'd respond to people here in bulk and take you through how it works. I'd like to think it's relatively straightforward, but of course, when you build something, you do. So this is the main page. When you first log in and sign up to QSEM, and to do that, you can actually launch QSEM up here and sign in and register for free. It's still experimental. We're receiving feedback. There's a long way to go yet and could change, but for all intents and purposes, this is how it looks. You've got model statistics on the left of your drawing canvas. So this is the drawing canvas here. And if you recall from the webinar, we went through impact, control, and time delay. Well, now what users can do is you can actually see on the left the breakdown, the frequencies and proportions of how many scores you've assigned to the various levels of your impact, control, and time delay categories. So it provides a snapshot. Are you dealing with a system with a lot of long time delay scores here? Are the participant group and researchers or the modeler, are they leaning towards longer delays or smaller impact scores? Or it just provides a nice quick snapshot for you. I'll show you the spatial 6 sensor tracker when we have a model up and how that works. Across the top here is your toolbar, so you can add factors like so and move them around your canvas. And then you can click connect. Now, when you click connect here, unlike other software approaches, it's persistent, so it's always on. So you can draw models really quick. So what you can do there is I can add a number of factors and move them around the canvas like so. And when I connect, it's dead easy. The good thing there is you can just connect like so, and before you know it, you've got something that's workable. And to actually move your connection points around or your relationships, you drag this green control point as so. And so at the end, you can sort of make a nice sort of well-presented model by using those there. Ghost factors and ghost variables, I've had a few questions around these. This is something that is found in existing packages. But if you can see new factor 5, for example, here, if I ghost new factor 5 because I want factor 5 to connect to factor 4, then I can connect factor 5 there. So factor 5 connects to 4, but it does so through a ghost variable for clean model presentation. If I was to connect the original factor 5 to factor 4, that relationship will disappear, of course, and like so. So it keeps track of your relationships at all times. And that's what this little sort of GST, ghost acronym is for, n equals 1. If I'm to create another ghost of factor 5, like so, and connect that to factor 6, you can see we have n equals 2 because we have two ghosts of factor 5 now. So it allows users to keep track of elements within the model. It's just something I noticed that working with participant groups and teams, as much hand-holding as possible when developing models and providing real-time feedback to users like here and your annotations really helps people. And of course, you can turn them off at any time by clicking phase 2 in the toolbar, like so. So that's what ghost variables do. You've got undo and redo. Now, phase 1 will make a lot more sense now. Phase 1 is where you actually assign your steering, measuring, ambivalent, and autonomous classifications. So I've not assigned any impact to control scores yet to the relationships on factors. So our slider, when we slide our impact and control quick controls here and press phase 1 to update our colors, there won't be a change because it's all equalized. We have impact to impact control. But let me just change the double click on this particular control point here. Let me just change the impact to 3 for new factor 6, and I might reduce control to 1, time delay to 2. Okay, and I've reviewed that now as a researcher without my participant group. So I'll click reviewed. Now it's gone yellow. If participants have reviewed it, perhaps you lock in final. So we know that we're happy with those scores. But what I'll do for now is I'll go reviewed. I'll also change new factor 6's impact on new factor 4. I'll put 3, like so, reviewed. Now, if I go to impact and then refresh phase 1, you can see the intensity of that color associated with new factor 6 is now a deeper red. That's because that happens to be the strongest steering factor within the model according to our impact slider. It's right at the end. If I go to control and refresh our colors, it will no longer be the strongest because our control scores will determine within that network what now happens to be the strongest control-based factor. So I'll slide it back up to the high end here, impact 100%, refresh always hit refresh at the moment, phase 1. We're working on optimizing that so it's all automated. If you look at the QSEM phase 1, you can see new factor 6 is indeed very strong. If we were to move our system around, you can see how our factors, when we move our slider, move around our system grid. So that system grid talks to the colors on your canvas, on your model there. And notice as well, all of these little information buttons that you'll see around, and some are hidden, some are embedded. If you press those info buttons, it'll give you information that's useful to your participant group. So when you share this software with participants and say, hey, register for free here, import a model I've built, and I'll show you how to import models up here. You can load models. Please make sure you read this because it will bring you up to speed with how QSEM works. And the stakeholders or participant group says, oh, that's brilliant. That's a nice little introduction for me to understand what you're doing. If you double click on your connection properties dialog box, if you bring it up and you press info here, model statistics, it will give you the definitions for impact, control, and speed. And so participants can actually ask themselves the questions to help them support with that scoring. So look out for those little info boxes if you can. Themes are really cool. What you can do with themes is you can click on factors. I might hold control down and select multiple factors like this and click factor in the themes group. And I might select health as a theme for those factors and I'll click save changes. And I might select new factor 2 and new factor here. So I keep saying new factors because I've not renamed them. I've got another model to show you if you want, but go factor and let's go technology. You can enter a custom theme name and even change the theme color if you wish and press save. Now what I can do is I can press group and it will show me the connections between each theme within your model. So intra-theme sits above the theme box technology and inter-theme as well. And I'll ungroup them there so you can zoom right out. Now you'll see on our spatial 6 sensor tracker, now we're building a model. that it will always keep track of where you are on the canvas. So I can use WASD and move around like that with my keys. So if I decide to build a subsystem and create a bit of space, I can do. Perhaps I want a subsystem, add a subsystem around this particular network here of factors, and I'll lock that in so I can move them around, and I might rename that subsystem up here, you know, policy factors or whatever you want to call it. Could be emergency first response. You know, you think of the subsystem name, and then you'll eventually, you might create a factor over here and connect that subsystem to another subsystem like that. And at the moment, you'll see all the connections are gray. They're gray because it tells the user you've not assigned your polarities. So I'll assign my polarities like so, balancing and reinforcing polarities. Now, once you've done that and assigned, or as you're in the process of assigning them, you'll see up here in the loop registry, we have a tracker. And what that tracker does is tell you that you have 8 of 11 connections classified, and it will tell you to keep continuing classifying to form loops. So I'll quickly classify all of our connections as so. Get that little one there that's hiding, like that. Now it says all connections classified form feedback loops. What you'll do there is you'll refresh your loops. If you hit refresh loops, you'll now see all of the loops in your model. Just so happens we've got 1 reinforcing loop and 3 balancing loops. Obviously, I've just assigned those polarities quickly. What you can do is you can highlight where is that reinforcing loop. Now, of course, it looks strange because it's a ghost factor, new factor 5, but what I'll do is I'll just connect factor 5 there just so you can see it a bit clearer and refresh the loops. It's still there, just make it a bit clear for you. So, because ghost factors are the model presentation, but they can sort of hide the feedback loops a little bit. And then we can add a loop label. I'm currently coming up with text annotation, so you can actually annotate your loops as well and add some description to that. That's on its way, won't be long off. But it's really nice then, because what you can do is you can highlight your loop and then you can export your model. Let's just go PNG for the time being, and you can open that. I don't know if you can see that when it appears because I'm sharing my screen, but you can actually visualize that here. I don't know if you can see that, but then you can share that as a high resolution with your stakeholder group and annotate it and so forth, and share that info. But look how quickly and easy it is to use in terms of, I mean, we've only just, developing a mock diagram here, but it's dead easy to use. And just de-highlight that there, and you can look at other balancing loops in the model and, add a label there, B3, and describe that particular connection and update your scores and time delays at any time. And for stakeholders, let's find out where the greatest sort of time, quickest propagation of influence might be. You can see here new factor 5 to new factor 6. It's very slow between these two factors. And the QSEM influence propagation tab, that actually shows the speed based on where they are in the system grid. Bit more, but time delay is very useful. So what I might do, Fernando, there is, because there's a bit more to go in terms of annotations to help people there, and maybe I'll go to some questions so I'm not absolutely drowning out everyone with my constant talking.
Let me quickly share my screen here then.
If there are any.
Yeah, I'll share my screen, but is it one takeover? Yeah. So how can we distinguish stock and flow factors?
Yeah, stock and flow factors, they're, I mean, if you go to the Bible or one of the Bibles, I don't know if you can see that, that's Business Dynamics by John Sterman. There's lots of information in there around how to distinguish or determine what are stock variables and what are flow variables, as well as other academic articles that delve into that. This is this could be used to identify stock and flow variables, just like any CLD modeling approach, if formal modeling and simulation is on the agenda after QSEM. But yeah, think of, if you were to freeze the model at any given time, what are the quantities and elements that you're interested in? Like when you freeze a model, it's your bank balance that you're interested in. That would be a stock, whereas the payments into your bank account would be a flow. I mean, yeah.
And Are stakeholders the only source of data to build the model interactively, or can data be collected through a questionnaire or other means?
Great question. And the answer is absolutely. You can use many approaches to model building. This isn't specific to QSEM. This is model building in general. So the answer is yes, you can use a questionnaire. You can use existing information and data. And in fact, the article by Jalali in System Dynamics Review, the qualitative special issue, on best practices, strengthening the weak link, I think it's called, goes through this the multiple ways in which you can build models. And he actually talks about how if you do it properly and you're transparent and report the data sources, if you haven't used a participant group, that makes for good model building practices because it allows people to understand how you've built the model and bringing that rigor to model building. So yes, certainly build a model without a participant group if you wish to. Yeah.
And how flexible is the software in modifying the weighting systems for the dimensions you have defined, such as control, impact, delay? Can you consider using a weighting structure that may be determining hard data statistical indicators?
Well, I can certainly, depending on the remaining time, show
We have
the
40
questionnaire that
minutes.
through. Yep, good. Yep, I can go
Yeah.
through that. And in terms of the second part of this question, that's really interesting. I mean, if we weren't using fuzzy inputs and weights on connections, is there a way of using a structure that may be based in more sort of empirical reasoning, using hard data? Possibly, yeah, there could be, but at the end of the day, this is supposed to be used with participant groups, and it's fuzzy weights for a reason. But you can change them at any time. Those weights, yeah, good question.
Is QSEM a better platform to build CLD compared to Vensim?
Look, I think it comes down to personal preference. Vensim's
Right.
fantastic. Vensim and Stellar are incredible packages. But they are geared towards simulation modeling, core system dynamics. They're brilliant. Vensim is a brilliant piece of software for drawing causal loop diagrams, and I would encourage people to use what they feel they enjoy using.
Right. Thanks, Adam. And last one here is, can you show the DDM?
Yeah, absolutely. I'll bring up the DDM now, Fernando.
Right.
In the
So I think you have 10 minutes to wrap up, Adam. And I'll
Yeah,
stop sharing
okay,
my screen. So I'm
that
closing
sounds good.
Q&A again.
I'll quickly share this.
A quick question that just came up,
Oh,
Adam, is
yeah.
can you import Benson or Stella models into QSIM and vice versa?
I'm looking into that at the moment. Not yet. I think that requires a further discussion and exploration, so I can't
Right.
comment yet. But it's something I've thought about, but I'm not going to act on that anytime soon.
Good. Were you going to go back to the software or and demonstrate on any something else or no?
Very briefly, yeah, that DDM and
Right.
the loop,
Mhm.
the dynamic loop register, and I'll wrap it up really quickly. Um, I don't want to outstay my welcome. Okay, I'll share this here. So that's the model we were going through and building. Very quickly, back to database, you can add a description. Example description added, lock that in, show where that factor is, and then when you click on it and hover, you'll get a floating tooltip. So people can understand what you mean when you've added that factor. What does that what is the definition of that factor and what are your thoughts around it? Exactly the same as your linked database, impact, control, and time delay. Add your justification. Impact is 3 because, and then lock that in. Sorry for my typos. Control is X because, and then if you show that particular connection in the model, you can see it's highlighted here. Just click it once and then hover, and then if you hover over it, you'll see a floating tooltip just to provide a justification around your impact and control reasoning. Someone asked about the DDM. Um, you can see it's being populated in the background autonomously, so it will progress and regress. It will change depending on your model, the DDM. And that's used, of course, for QSEM phase 1 and QSEM phase 2 there. So QSEM phase 2 is your loops of interest, and your dynamic loop register is down here. So when I mentioned in the webinar around prioritizing loops of impact, so let's go impact and let's make it a strong loop, I can use the sliders like so. If you're lazy, like me sometimes, you can go, I just want slow control loops or fast and independent loops. So you can use your preset buttons like that. I sort of like the sliders sometimes. So you might do that. You'll see it resorts your dynamic loop register automatically, and then you can actually highlight your loop from there as well. So clear all highlights there, go back and highlight your loop according to those particular coefficients, those metrics. And you might want to highlight loops that are, really, really fast, for example, and or really slow. If really slow, click this button there, and you can see the DLR below will change depending on if I want fast or slow loops. So I want slow loops, and highlight that there. And it's slow because I've added a time delay here. If I click this and add 0, of course, the 3 little notches will disappear. If I add 2, you'll see 2 symbols, lines. And don't forget to save your model like so, and load your model, and you can share that with participants. So I'll load a model here. Okay, can bring up a model and share that with stakeholders, and everything is retained. All of the factor database info, link database info, all of your results are retained for stakeholders, and they might then verify and click final, and that once they're happy with all of your connection scores. And they're the factors. Last thing, if you click the star, you'll actually highlight factors that are the most connected within the model. So factors that participate in the most feedback loops will be highlighted there, and you can turn everything off as well if you don't want if you want clean models. All right, I'll just due to time, I'll stop sharing my screen there, and hopefully that was somewhat helpful.
Yeah. Thank you so much, Adam. This was very, very helpful, very insightful webinar, really well structured. So thank you so much for your presentation. I know it's quite late in Australia, so giving everyone
3
a few
now.
minutes back. And thank you everyone for joining. We have another webinar in 2 weeks, so I'll be happy to see you guys there. And also, again, come to join us in the Netherlands, in Delft, for the conference. I hope to see you there. And also, you as well, Adam, hope to see you in the Netherlands.
Thank you, Fernando. Thank you very much. Thanks everyone for coming. Really, I loved it. Really appreciate your time.
Right. Thank you, everyone. Have a good one. Bye-bye.